Hey guys, so today we're going to talk about waves. All right, and this is going to come from the state standard P86. All right, so here listed are some very important vocabulary that you'll hear mentioned throughout the lesson. These are also some of the same vocabulary words that you're required to complete your vocabulary assignment inside of your interactive notebook as well in your assignment that you have today. Um, you'll use 10 of these words, complete them in a Freire model where you will find a picture for them, you'll write a definition, you'll write a characteristic, and you'll give an example for it. All right, so students will demonstrate an understanding of the properties, behaviors, and application of waves. All right, and the main ones that we're going to look at today, we're going to be able to collect, organize, and interpret data about the characteristics of sound and light waves to construct explanations about the relationship between matter and energy. We're also going to be able to investigate research based mechanisms for capturing and converting wave energy, which includes your frequency, amplitude, wavelength, and speed. And we're going to convert those into electrical energy. All right, big idea. So, the main question that we're trying to answer here is going to be how can we use characteristics and behaviors of light and sound wave to explain the relationship between matter and energy? All right, so jumping right into it. So, waves are rhythmic disturbances that carry energy from one point to another in the direction that the waves travel without transferring matter. All right, so down here at the bottom, you can see how the wave is transferring from one point to another point. All right, so these are often called vibration. Um, you'll see another word called oscillations. Oscillations just simply mean up and down or back and forth movement. All right, so there are two categories of waves that we're going to look at. We have mechanical waves and we have electromagnetic waves. So, waves that move through matter are called mechanical waves. All right, so once again, these waves use matter to transfer energy. And then waves that move through vacuums are called electromagnetic waves. So these are the waves that will transfer energy with matter. So think of a vacuum cleaner that's sucking every bit of matter out of space. All right, so that when I refer to a vacuum, waves can move through matter or through vacuum. So vacuum is just a space that has no matter in it. All right, so first we're going to break it down and we're going to look at mechanical waves. All right, so remember these are one of our two categories of waves. All right, so mechanical waves, the matter in which mechanical waves travel through is called a medium. All right, it's called a medium. And a medium is just something like a solid or a liquid, or something that it has to travel through. All right, so I'm gonna give you two examples. All right, so the first example, waves in water created from the back of a speedboat is an example. So the energy travels from the water molecules to water molecules, making a ripple. So that's why you see the water going up and down, making a ripple. Another one is talking, and when you talk, you create sound, which travels by transferring vibration from molecule to molecule and move the sound from ear to ear. All right, so once again, the two examples are waves in water that you can create from the back of a speedboat. Another one would be something that we do every day, talking, which creates sound waves. All right, so mechanical waves can be either transverse or compressional or longitudinal. So compressional, longitudinal are the same, or they can be transverse. All right, transverse waves are waves that cause matter to move up and down or back and forth at right angles to the motion of the wave. So just like I was talking about the water in created from the back of the speedboat, so those would be transverse waves. All right. So here's the example. You see the water is going up and down in an up and down motion. So once again, that is called transverse waves. That's up and down or back and forth at right angles to the motion of the wave. So that example would be water waves. All right, then we have longitudinal or compressional waves. Um, these are waves that are caused by matter in the medium, which moves forward and backward in the same direction as the motion of the wave. All right, so when we're talking about longitudinal and compressional, and I'm going to explain in a minute why they're called that. So you see at the bottom down here, we have like a slinky, and then over here we have sound waves. So if you notice, the slinky spreads out in certain parts, and then in certain parts, it's kind of compacted together. All right, so longitudinal and compressional just means that it is pushed together and pulled apart. All right, so a more technical term for it would be rarefaction and compression. Rarefaction is when particles are farther apart, and compressions is when they're squeezed together. So if you take when you buy a brand new slinky, it's pushed together. That would be compressed. So those are compression waves. Once you pull that slinky apart, then it will be refracted because we're pulling those particles farther away from each other. All right, so then we have sound waves. Sound waves is caused by colliding air molecules, so no sound in space. So think about it when you see astronauts that go in space, they often have to have those radios inside of their helmet because that is a vacuum. Basically, no air is there, so you know sound can't travel through space. All right, now we're going to look at the parts of the wave. We often refer to it as wave properties, or you can say the main characteristics of waves. So we do have four main characteristics of waves. All right, and if you look here, there's that example, that longitudinal, like I was saying here, they're close together, so they're compressed. Think about it in a way, if you press a can down, all the way down to the ground. So it's compacted together, it's pressed down. All right, and you see those rarefied molecules, they are pulled apart. The transverse wave, once again, as you can see, it goes in an up and down or back and forth motion at a right angle to the wave. All right, wave properties. So we're going to talk about the four main properties of waves. The first one is wavelengths. All right, wavelengths. All right, so wavelengths measure the distance between two identical points on a wave. So it'll measure it either from here to here, which those are called crests. So let me go back. All right, so the top part of the wave is a crest. It's a crest. The bottom parts of the wave here and here would be your trough. All right, so the two top parts are your crest, the two bottom parts are your troughs. When you measure crest to crest, that would be your wavelength. All right, so crest to crest or either trough to trough would be your wavelength. Amplitude would be basically how far from the resting point up to the top of the wave that it goes. So back here, crest to crest, trough to trough. So here to here. And then another example will be from here to here. All right. So when we're dealing with trough to trough, from here to here, and then from here to here. All right. And compression would be from here to here, or either here to here. So we're just measuring how far the top of the wave or either the bottom of the wave is. All right, the next wave property we're going to talk about is frequency. All right, so frequency of a wave is a measure of the number of waves that pass through a point each second. Excuse me. So basically, it's the number of waves that pass a certain point in a given amount of time. All right, so it's the number of waves that pass a certain point in a given amount of time. All right, so the higher the frequency, the shorter the wavelength. The higher the frequency, the shorter the wavelength. All right, and so it'll go vice versa. The lower the frequency, the longer the wavelength. All right, so if you look here and remember wavelength, we're measuring from crest to crest. So if you see you have more space here than you do in the high frequency. So a higher frequency, you have a really short wavelength from crest to crest. But if you have a lower frequency, you have a longer wavelength from crest to crest. All right, and so we measure those in units called hertz, right? So frequency is measured in hertz. All right, so our next property we're going to look at is amplitude. All right, amplitude measures the distance a wave travels from its original position. It relates to the amount of energy a wave carries. High amplitude causes brighter light, and lower amplitude causes dim light. Higher amplitude causes louder sound, and lower amplitude causes softer sound. So think of waves in an ocean, okay? Waves in an ocean. All right. So we're talking about waves in an ocean. The waves that carry more energy are taller and are farther apart from the regular water line, so they have a longer amplitude. All right, so for example, let's think about two different things. Think about 10 waves pass a dock in 10 seconds, okay? Which means they have a higher frequency. All right, and then we have two waves that pass a dock in 10 seconds, which means they have a lower frequency. Excuse me. All right, so in the first situation, the 10 waves have to pass in the same amount of time it takes for the two waves to pass because the waves are traveling at the same speed. So the 10 waves must be closer together, which means they have a shorter wavelength. So remember, higher frequency equals shorter wavelength. Excuse me. All right, so our next property would be velocity, and velocity just simply means speed. All right, so the distance a wave travels in a given amount of time would be your velocity or your speed. All right, so the medium that a wave travels through affects the speed of the wave. All right, so the medium that a wave travels through is affects the speed of a wave. So just think about that. Remember, we talked about mediums can be something like water, something like air. It can be a drum. It can be a cup. It can be your hand. You can hit on the desk and make a sound, and your hand would serve as a medium because those waves are passing through there to make a sound. All right, so waves travel at different speeds in different mediums, is what they're saying. So they travel at different speeds in different mediums. All right, so mechanical waves travel faster in solids than in liquids or gases because particles are close together. All right, electromagnetic waves travel fastest in gases, slowest in solids. So let's think about mechanical waves such as sound. What do you think it will travel faster in, water or air? All right, so it'll travel faster in water than it do air. All right, electromagnetic waves. So electromagnetic waves are light waves. All right, so what do you think they do? They travel faster in air, or do they travel faster in water? So they travel faster in air than they do water. So just think about when you stick a pencil in water, it looks kind of distorted. It kind of looks like it's almost broken. And that's because the light waves reflecting off the pencil are traveling faster in air than they are underwater. All right, so let's look at this diagram. Let's look at this diagram. All right, so remember our crest is our highest point here and here. Our trough will be our lowest point, which will be here. Wavelength, we're going to measure from either crest to crest or trough to trough. In this case, we only have a crest to crest, so a measure here. Amplitude is going to measure from here. This line here will be your resting point. So it's going to measure from here to here. So basically kind of like how tall the wave goes up. All right. So longitudinal or compressional, we need to figure out which ones are rarefied and compressed. So look at what they're pointing at. Are these closer together or are they farther apart? Are the ones that they're talking here closer together or farther apart? All right, so look here. This one and this one are closer together. So remember, when they're close together, they're almost like they're being pressed together. So compressed. So there's compression. The ones at the top are farther apart, so they will be rarefied. Same here. These are farther apart, so they'll be rarefied. Um, these here will be compressed, so there will be compression. All right. So what you guys need to do, you need to go in and complete the anticipatory student explanation. So imagine that your family had just returned home from a day at the beach. You had fun playing in the ocean under a hot sun. You put some cold pizza in the microwave for dinner. You turn on the radio. Just then, the phone rings. It's your friend calling to ask about homework. So read the event described, read it over. Identify how many ways you think are present and what kind of ways you think they are. So this is no right or wrong answers, just to see what you can pinpoint. And then when we get done talking about the types of waves, we're going to go back and I'm going to explain to you what was identified here. Also, go ahead and complete the label diagram. Remember, all you have to do is click them and then just drag it to the correct location. All right, so once you finish those two guided practice, I need you to go over to Schoology. And in Schoology, go to your Waves folder, um, click your Tuesday folder. Inside that folder, you'll see your vocabulary assignment and you'll see a small worksheet. And I need you to complete the worksheet. The worksheet will be due today at the end of your class period. The vocabulary, it does take a little time, so I will give you until Friday to complete your vocabulary. All right, so if you have any questions, if you need any additional assistance, make sure you email me ASAP at jasmine.mcbride@hattiesburgpsd.com, or you can simply log on to our Google Meet link and I'll be present on there for your entire class period in case you need some clarification on what I just went over, or I'll be available from 2 to 2:50 for additional assistance. Have a great day, you guys. Make sure you complete all of your assignments.